Hi, this is Mr. Franklin, and I'm going to run through the Math 2 homework that was due today. We've got some directions up here. Graph using the intercept method. Think about the scale before you plot the points. Solve the system of linear equations. Label the solution on your graph. And check your solutions. That means plug into both of the equations to make sure we've done it right. So we're going to do the first equation first here in this box, and we're going to plug in 0 for x. 3 times 0, of course, is 0. So we've got the rest of the equation is y equals -3. And that goes right here. Additionally, we've got the y component is 0. If we plug in y equals 0, then we can just cover up this bit here, and we see that 3x equals -3. Dividing both sides by 3 gives us x equals -1. Let's plot that line. Now the directions reminded us to think about the scale, and on this graph right here, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 spaces on the y-axis. Since our points are 0, -3 and -1, 0, I think that going up by ones makes sense. So on the x-axis, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and on the y-axis, and then in the negative y-axis, we've got -1, -2, -3, and so on. And we have scaled the graph. Hope it's right, because I'm doing this in pen. So we're going to plot our 2 points. Those 2 points, of course, are 0, -3 and -1, 0. So 0, -3 is 0 along the x-axis. That's right here. And then down to -3 on the y-axis. And that point is what's called the y-intercept. And that's why this is called the intercept method. And then we've also got the point -1 on the x-axis, 0 on the y-axis. And I'm going to use a ruler. Notice I'm not just connecting the points, I'm drawing the line from the top of the graph to the bottom of the graph. And there we go. Now, any point on this line is a solution to this first equation. That means that the x and y coordinates of any point on the line will make this equation true when we plug in the x here and the y here. But what we really want to know is, where do the 2 lines meet? So of course we need to graph the second line as well. So let's do that. Same method. When we plug x in for 0, we've got 2y equals 4. 2 times what equals 4? The answer is 2. And of course, if y equals 0, then we've got just x equals 4. X equals 4. When x equals 4, y equals 0. When x equals 0, y equals 2. Those are our 2 points. Let's put those on our graph. I think they'll fit the scale we picked. 0, 2. And 4, 0 is right here. And hopefully, with your mind's eye, you can see where approximately they're going to meet. But let's be a little bit more exact than that. With the ruler, trying to be careful here. when we draw that, now we can see that there's a point right here where the two lines intersect. And that along the y-axis, we'll do x-axis first. Along the x-axis is -1, -2, and then up to 3. So the coordinates of this point right here are -2, 3. For completion's sake, and that's the answer. For completion's sake, let's go back here and just double check that those work. I'm just plugging in x equals -2, y equals 3 into this equation. 3 times -2 plus 3, that would equal -6 plus 3, which is -3, which is what we needed. It works in that one, but please beware. It can't just work in one of the equations. To be the solution of the system, it has to work in both of the equations. Let's try. Plug in x equals -2 plus 2 times 3. So that's -2 plus 6. And that equals, 4. 6 minus 2. There we go. So we have successfully done that one. I'm going to go a little faster on the next ones. One of the warnings here is to think about the scale on this. On the graph, I don't know if going up by ones is the right thing to do. Let me do a little math first. What I'm going to do is I'm going to find all of the intercepts, the 2 intercepts for this equation, and then the 2 intercepts for this equation, and see what my highest and lowest values are, and use that to determine the scale. Because these are bigger numbers this time, I think we might have to make some other choices. But just going through and finding the intercepts, when x equals 0, then I've got 8y equals 60. Now I know that 60 divided by 8 isn't going to be a whole number. Using the calculator, I can see that it is 7.5. Over here, though, when y equals 0, then 2 times what equals 60? Well, that one I know is 30. Similarly, for the second equation, which is going to be these boxes, when x equals 0, then 5 times 0 is 0, so I can just cover this up. -2 times what equals 40? The answer is -20. And over here, when y equals 0, then I've got 5 times what equals 40? The answer is 8. Noticing in here that my numbers are a little bit bigger than before. If I go up by ones on the graph, of course, I'm not going to be able to get to 30 or -20. If I go up by 2s, I don't think I'll get there either, so I'm going to go up by 5s. 5, 10, 15, 20, 25, 30. That ought to do it in all the directions. 5, 10. And of course, in the negative x direction. Now, going up by 5s was not the only choice I could have made. But it seems reasonable, and I like the 5s times table, so I went with it. I'm going to graph the 2 points for the first line first, 0, 7.5, and 30, 0. So 0, 7.5. 7.5 is, of course, halfway in between 5 and 10. Not too hard to find that one. And then 30, 0. That's kind of why I stopped going up. Now, I recommend, as soon as you put the points, the intercepts for one line, draw in the line. Don't place all 4 points first. It's too easy to get confused about which one goes where. But you probably already knew that. 0, negative 20, and 8, 0. Now, 8, 0 is going to be right about here, but it's a little bit more than half. Please understand that everything about using the graphing method is based on estimating. Whenever we graph, the best we're doing is an estimate, because it's very hard to be exact when you're drawing these. It works out pretty well this time. But that's why we're going to explore some algebraic methods next for solving these. So that point right there, of course, don't fall into the trap of thinking that that is 2, 1. We have to use the scale that we've got. So this is the point 10, 5. 10 in the x direction, 5 in the y direction. Let's go back here and make sure that that works. So the solution, 10, 5, let's double check. It'll be really embarrassing if I'm wrong here, but let's give it a try. So 2 times 10 plus 8 times 5, that's of course 20 plus 40, and that is in fact 60. But we have to check both of them. 5 times 10 minus 2 times 5. Let's see what we get. 5 times 10 is 50, minus 2 times 5 is 10, and that's 40. So our solution is correct. Here comes the back of the worksheet. When x equals 0, I get y equals negative 2. And when y equals 0, I get x equals 8. Over here for this other line, when x equals 0, 4 times what equals 16, I get 4. And when y equals 0, x is 16. Over here to the graph, thinking about my scale, the biggest number I have is 16, and I only have 9 tick marks. I'll go up by 2s this time. And I'll be able to fit the 16. That's really in the wrong place. There we go. 2, 4, 6. And the negatives. Almost lost count. Now I can tell where the points have to go, reminding myself of what those points are. Let me plot them here. 0, negative 2 is right here. 8, 0 is right here. Drawing my line. Zero, 4, that's positive 4. And 16, 0. Draw that in. Notice that the intersection point of where I drew my lines is not exactly on the tick marks. That's not really a problem. I think that this point is 12, 1. Let's go over here and plug that in and see what we get. 12 minus 4 times 1. 12 minus 4, of course, and that's 8, so this one works. Plug it in here. 12 plus 4 times 1. That's 12 plus 4, which is 16. So my answer is right. The answer is 12, 1. Last one. Thank you for staying with me. What's 4 into 28? I think those are right. Scale my graph. Plot my points. Do you see what I see yet? It's -7, comma 0 is right there. And of course, these two lines now cross. You might have noticed as I was doing this that those 2 points appear on both lines. And that's backed up by seeing where they meet on the graph. Let's plug them in though. 0 plus 7 times -2, of course, is -14. 4 times 0, of course, is 0, plus 14 times -2, that's -28. So our solution was right. We didn't actually need to graph this one. We found the solution when we made the tables. Happens that way sometimes. So on all 4 of these problems, we used the graphing method to find the solution to the system. And now you have the answers to the homework. So thank you very much if you got to this point in the video. Please stay safe, stay sane, and I will see you again next time.